Hello everyone, we are from Group 4 and we're here to present about the factors to adhesion strength of passive suction cup, a design of experiment approach. Our group members are Samuel Adam, Zaki Taufikul Hakim, Amir Faisal, and Fadil Mahaputra. Next. Firstly, we have background and research purpose. For the background, in engineering, there are various work areas that require tools for gripping in manual or automated application. And this is where the suction cups plays role. Suction cups are tools that stick to non-porous surfaces and create a partial vacuum. And the suction cups adhesion strength need to be tested in order to ensure their work effectiveness. This research would investigate factors affecting the adhesion strength using 2 to the power of 4 factorial design with 2 replications. For the research purpose, there are 2 purposes, in which the first one is discovering the main factor affecting suction cups adhesion strength, and the second one is applying design of experiments, expanding class, especially 2K factorial design to solve a real-world problem. Next. This is the suction cup work principle in which there are 4 phases. The first one is initial phase, when the suction cup is in contact with the surface. The second one is pushing phase, when an external pushing force is applied to the suction cup. The cup deforms and air inside the cup is squeezed out. The third one is attached phase. It is when the pushing force reaches its peak value, it acquires a new force balance under the gauge pressure force. And the last one is detached phase. It is when the payload force is a pulling force and exceeds the maximum air pressure force. The suction cup detaches from the surface and enters the detached phase. Next. Actually, there are 6 possible factors affecting suction cup adhesion strength. But for this research, we only include 4 out of the 6, in which the 4 are diameter, surface structure, moistness, and environment temperature. For diameter, larger diameter suction cup will have larger vacuum area with lower internal pressure. It will create a larger difference between the ambient atmosphere and inside the suction cup. The second one is surface structure, in which the rough and irregular surfaces could potentially cause air leakage in the contact zone to the inside of the suction cup, leading to lower adhesion strength. The third one is the moistness of the suction cup. When the suction cup is wet, the water will fill the gaps on the edge and prevent air leakage. Lastly, the last factor is environment temperature. When the temperature is too cold, it can hinder the cup's flexibility, resulting in worse overlaps compared to warmer environment. Next.
So here are the factors and levels for our experiment. Like Emir said before, we are using a diameter, surface, temperature, and moistness with 2 different levels, which is low and high. Low level indicates it has 3 cm diameter, cool surface, indoor temperature, and dry moistness, and vice versa for high level, which indicates 5 cm diameter, ceramic surface, outdoor temperature, and wet moistness. Next. So during the experiment, we are using Newton meter by showing Newton level number just before the suction cup is detached from the surface. At the right side, we have our run orders with 32 trials or 2 to the power of 4 with 2 replication with the factors and levels. And we also provide the slow motion video as the slide shown. And this is the step for the data processing in Minitab. At first, we create the factorial design. Then we analyze the factorial design. After that, at the next slide, we conduct the normality test using the Kolmogorov-Smirnov method. And we also create the absolute residual. And the last step is testing for the equal variances as the step at the slide you can see.
So here are the data that we have collected during our experiment. Next. So after collecting the data, we need to check whether the model is adequate enough for our experiment. So as we can see in the probability plot graph below, the graph shows that the data is not following the trend line and the p-value is larger than 0.05, meaning that the data is normally distributed. Next. The next one is that we need to do the independence test. As we can see in the versus order graph below, the data is randomly distributed and doesn't follow any particular pattern along the distribution, meaning that each data from each factor can be determined as independent. Next. And lastly, we need to do the homogeneity test. As we can see in the versus fits graph below, the data is scattered, shows no clear pattern, and the p-value is larger than 0.05 as well. This means that it fulfilled the homogeneity of variance assumption. We conduct the task for equal variance using the Bartlett's test since it is more sensitive and has better performance than Levin's test as long as the data is normal, which we have proven in the first test that we have conducted. Next.
For the model interpretation, first we have the main effects plot. By visual interpretation, diameter has a significantly steeper line compared to the other factors. It implies that the change in diameter has the highest effect to the force needed to detach the suction cup. And secondly, we have Pareto chart. Similar to the main effect interpretation, diameter is the only factor deemed significant, passing the red line threshold. And for the interaction plot, based on the parallelity, diameter versus temperature, diameter versus moistness, temperature versus moistness, and surface versus moistness are intersecting each other, thus indicating interactions. Although that doesn't mean that it is statistically significant factors. We have to check it through the ANOVA. And on the analysis of areas or ANOVA, strictly following the 0.0 p-value cutoff, the only significant factor in this experiment is the only diameter. Although the temperature versus moistness and diameter versus surface versus moistness are close enough to 0.05. So for the conclusion, the data has fulfilled the model adequacy test. The data is normally distributed, it is independent, and also the data variance is homogeneous. Although all the second order interactions showed interaction for each other based on the interaction plot, they are not statistically significant on the ANOVA. And using ANOVA test, supported by the main effect plots and Pareto chart, the only factor deemed statistically significant is diameter of the suction cup, affecting the adhesion strength positively. That's all from us. Thank you for listening.